So here's what I've learned. Videoing at night, not a good option. Bad overhead lighting. Pretty rugged looking because I'm super tired, but we're going to make this work. So please forgive my tiredness. Here we go. Today we're learning about volume of spheres. So if I ask you guys what a sphere is, hopefully most of you guys will come up with a ball of some kind. But what is a sphere? Hopefully you guys are thinking about a circle. But a circle is a 2-dimension figure. A sphere is a 3-dimension figure. So this is the closest thing I have to a sphere in the house because I actually don't have any of my sport balls in the house. So I'm going to use my dog's toy. It is not actually a sphere. It's kind of oblong. Kind of looks like an egg. A little squeaky toy of some kind. But anyways, so let's pretend it's a sphere. So a sphere is basically a 3D circle, okay? Facts about spheres. They do not have any edges. They do not have any sides. They do not have a height. This is the hardest, and man, I wish we were in class to do this because the arguments that come out of this, because when I tell you this sphere does not have, remember we're picturing this as a sphere. When I tell you this doesn't have a height, most kids are like, wait a minute, no, I don't agree with this because I could put this down, right? I could put this on a surface, stick a ruler next to it and go, oh, Mrs. Munier, look, I can measure this, this has a height. But it doesn't, because in order for something to have a height, you have to have a face. Not this tired looking face, but you have to have a face on the solid. And a sphere does not have a face. So if it doesn't have a height, what does it have? And furthermore, how do you make a sphere? Do you just have a bunch of circles that you cut out and you place them down and build one up? How do you make a sphere? And oh man, the discussions that come out of this question, because you'll get ideas and kids will be like, oh yeah, no, it's a circle, and then you open it up. Like, okay, we've talked about nets, and when I talk about the net of a cylinder, you can actually very clearly see the top and bottom of a cylinder is a circle. And then when you open it up, you get a rectangle for the body. We didn't really talk about it during cones because I was gone again. But like if we talk about a net for a sphere, like if I open this, what would it look like? Actually, that looks pretty spherical right there. What would it look like? Do you have a true net? So if you open it up and you fold along edges, then we get stuck because a sphere doesn't have an edge. Although they do have a very, very good representation of a net for a sphere. But it's not true because the only dimension a sphere has is a radius. It is not a height. So when the argument came out about, oh, Mrs. Muner, this has got to have a height because I could stick it on something, surface, and I can, measure it here, and it's got a height. I can measure the height. But no, okay? Because if you place a sphere on a hard surface, right, technically it's supposed to round. It's supposed to roll because there's no face, there's no edge, there's no flat piece, if you want to call it that keeps it from moving. These are good arguments, and I might open up arguments for when I get back. So if it only has a radius, then that means we can have a diameter. But how do you make one of these things? This is my most favorite thing to discuss about when it comes to volume is how do you make a sphere? Hopefully you guys are kind of thinking about it a little bit. Maybe some of you guys aren't. Maybe you guys are just waiting for me to get to the lesson so you can, finish this, taking notes and get going on your homework. But this is a huge conversation because to understand a spheres, you got to kind of know how to make one of these. And it's not as easy as you might think. So here we go. In order to make a sphere, pick any point in space, okay? There's my point in space, all right? Now, you're going to take a unit of measurement, whatever you want to do, like 2 centimeters or whatever, 2 feet, whatever, Okay, so now from this point in space, you're going to make, let's say, 2 centimeters. 2 centimeter radii here, 2 centimeter radii here, and here, and here, and here, all starting from this point in space. And so if you have an infinite amount of these 2 centimeter radii coming from all directions of that point in space, if you have an infinite amount, which means you keep going and going and going and going and going until basically you die, it's going to fill in. Hence, that's how you create a solid. So it's just any point in space, right? And you draw an infinite amount of radii out in all directions, meaning in three dimensions. Stemming from that one point. Well, if you only have like 5 or 6 or maybe 200, you may not be able to see that it creates a sphere, pardon me. But if you keep drawing these radii, they're all 2 centimeters from every direction on that point in space, you will have a sphere. Pretty cool, I think. I really like spheres. Yeah, we can have lots of discussions about these things. So, with that in mind, the formula, okay? I have talked about how to derive this formula for a while, and every time I do, kids get stuck on the fact because the volume of a sphere comes from pyramids. Kind of weird to think about. So if you're really interested in how to what we call derive, D-E-R-I-V-E, the formula, take a look at the activity that's right before the lesson, and it talks about it in the last activity. I think it's activity 3. So it's pretty cool. Okay, so sphere, no height, just a radius, but if it has a radius, it can go out diameter. Remember, this is going to be my pretend sphere. My pretend sphere, okay? It's my dog toy. You ready? Here we go. 8.3, volume of spheres. And like I said, the lighting's really weird just because it's all overhead. I apologize. It's late. Here we go. So to draw a 3-dimensional sphere, you're going to try to draw your best circle. You're going to draw a curved front. It's pretty slight right now. Dotted back. So that's kind of like the back side of the sphere. Center. To the quote-unquote edge. Remember, you do not have an edge in a sphere. That's why I'm like quote-unquote. That is going to be your R from that center point out to the outermost part of your sphere. Okay. Now the volume formula. Volume is equal to 4/3 pi r cubed. It is not squared anymore, it's cubed. Okay. And like I said, if you want to figure out how to get this formula, it's in the activity. Okay. Very straightforward. Finding the volume of a sphere is very similar to finding the volume of a cylinder and a cone, but instead of squaring the radius like we have those other two, we're going to have to cube this radius. But the steps are the same. 4 or 5 steps are exactly the same. Okay, so let's get going. Here we go. Example 1. Find the volume. Round. What do you guys want to round to? To the 10th? How about that? Round to the 10th. Let's see. Okay. Alright, so draw a sphere. Okay. Sphere. Let's go with a radius. Let's go radius 6. Let's make it large. 6 feet. Okay. That's that guy right there. It's be 6 feet. Okay. All right. First couple steps are exactly the same. Step 1, you should be able to say it by now. Write the formula. V equals 4/3 pi r cubed. Okay. So it's power of 3. Second step is still the same. Plug in the numbers. Except for this time, there's only one number to plug in, and that is your radius. So volume equals 4/3 pi times my radius, which is 6. Always double check. It's a good thing to double check to make sure that they didn't give you the diameter. Because if they gave you the diameter, cross that off, take half of that first. 6 cubed. Okay, so I just plugged in my numbers. Step 3 is the same. Before it was square the radius, now it's going to be cube the radius. Okay, so volume is still equal 4/3 pi times. Now I'm going to show you how to do this on your calculators. New key. Okay, so we have 6. Okay, I gotta make sure you guys can see that. Oh, there we go. 6. Now to use exponents greater than a square, find what I call the caret key. It looks like a triangle with no bottom. It's that guy right there. That is your exponent key. That will allow you to take things to whatever power you need it to go. Okay, so hit that, and then you should see there we go, a little caret right there, and hit 3, then hit enter. So what you're telling the calculator to do is 6 times 6 times 6, which is 216. Okay. First 3 steps are the same. Write the formula, plug in the numbers. Now it's cubing the radius. Step 4, 2 things. Volume is switch to squiggles approximately. Okay. So now go to your calculator. Okay. So we have 4/3, so 4 ABC 3 times pi times 216. Okay, hit enter. Look at all those numbers. Are we writing them all out? No. So you have 904.77 blah blah blah. Blah blah blah. So the 2 things you have to do, your squiggles and your dot dot dots. Because remember, this is saying the number goes on and on and on, and it does not stop. Because if you didn't write your blah blah blahs, you're saying that this is the exact answer. It's precise. It is not. Because anytime you use pi, your number's going to go on for the rest of your life. Okay, so your dot dot dot, your blah blah blahs helps you make it really short. Okay, so now we go. Volume is approximately, we're rounding to the nearest tenth. Okay, we're rounding the first 7, so this 7 is going to push this 7 up. So we have approximately 904.8, and then your label, where are we at? Cubic feet. There you go. Very, 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 very similar. Step 1, the same. Write the formula. Step 2, plug in the numbers. Step 3, cube the radius. Before it was square the radius, now we're going to cube it. Okay? And you're going to use that caret key, which is the, oops, right there, the bottomless triangle. Okay? There we go. I'm going to use that key right there. And it's right above your x squared key. That's your exponent key. Okay? Step 4, switch to squiggles, blah, 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 and then round it. Same thing. Pretty straightforward. There's only one dimension, though. It's either a radius or a diameter. Whereas your cylinders and your cones, you have 2. You have your radius and your height. So there's that. Okay. Well, we're going to do a couple more. Considering how tired I am, I'm doing pretty good on this. There we go. Sphere, same directions. Let's go 15 meters. Okay. So the sphere has a diameter of 15 meters. So that's, like 45 feet all the way across. That's huge. Looks like getting a family-sized hamster ball and putting everyone in it or something like that. I don't know. It's pretty big. Okay? But they gave you the diameter. Anytime they give you the diameter, the first thing you're going to do, take half of that. So half of 15 is 7.5. You can write 7.5. You can write 7.5. I don't care which one you use, fractions or decimals. That is your call. Okay? Here we go. Let's follow it all again. Step 1, write the formula. Volume equals 4/3 pi r cubed. Cubed is the word that goes with power of 3. Square is the one that goes with power of 2. So it's cubed right here. Power of 3. Step 2, plug in the numbers. But it's just one number. I know it's easy to say plug in numbers because that's what we've been saying for 2 lessons. So 4/3 pi times my radius 7.5 cubed. Okay. Step 3. Cube the radius. Okay. So you're going to go here, 7.5. Caret key, right there. It's called the caret key, but it's technically really your exponent key. But it looks like the triangle with no bottom, right there. To the power of 3. And you get 4/3 times pi times, write all those digits in. 421.875. Okay? Keep all those digits there. Don't cut it off. Okay? All right. Now, step 4, 2 things. Switch to squiggles. So volume is approximately. Okay. Now multiply this all out. So here we go. 4/3, 4 ABC 3 times pi times 421.875. Whoa, I'm going to read backwards. 1,767.14, blah, blah, blah. Okay. So 1767.14, blah, blah, blah. Okay. We're going to round to the nearest tenth again. We're rounding the one. It kind of got squishy, sorry. So the 4, is it going to keep 1 at 1, or is it going to push it up? Hopefully you said it's going to stay there, because remember, this digit has to be a 5 and it is not. So volume is still approximately, so these last 2 lines you have to use the approximate sign, is 1,767.1 label meters cubed. There you go. Okay. Almost the same. You got to cube the radius instead of squaring the radius. That's about it. Okay. All right, now, unknown dimensions. Kind of like you had to find the height on, I don't remember if it was cylinders or cones you had to, whatever. But when you have to find an unknown dimension in a sphere, there's only one dimension, so what you're finding is your radius. So example 2, find radius. Okay. Let's go. What does that say? And I'm flipping back between the book. Okay. So let's draw a sphere. Okay. So you're just going to draw a sphere, and then since there's no numerical value, you're just going to put R, because that's the only dimension you can find. Okay. So if you have to find R, then that means they have to give you the volume. But the cool thing is about when you do finding radius problems on spheres, they do something a little bit different in the answers. Watch. And what units are we going to do? Inches. Okay. So the volume, they leave it in what we call terms of pi, which means it has the volume, but then it also still has pi in it. We like this. It makes it easier for us. Okay? So just make sure when you're doing the homework on this, double check to make sure they give you pi. If they do, so much better. Okay? That was weird. I just, on a video, something popped up. Anyways. Okay. Same steps. Write the formula. Volume equals 4/3 pi r cubed. Same thing. Okay. Step 2, plug in your numbers, but now it's just plug in the number, which is going to be your volume. Don't forget pi. You can't just drop it like some people drop in their last names. You don't get to do that. Okay. So 288 pi equals 4/3 pi r cubed. Okay. So like the cylinders and like the cones, this becomes a balancing problem. So you're actually going to solve for R. So circle R. Whoop. Okay. And so what happens is you have your fence, you are R, and you have best friend pi and best friend 4/3. You're going to send both of those best friends home at the same time. It's going to make it easy, okay? So divide by 4/3 and pi. Actually, you know what? No, I'm going to make this even easier. I'm going to change my mind here. I can do that. Okay? So, since both sides have pi, let's get rid of pi first and make it easier because then we're just dealing with numbers and we're not going to have to deal with the blah, blah, blahs. I changed up my mind. So, what we're going to do is we're going to divide by pi on both sides. Okay? Because pi divided by pi is 1. Pi divided by pi is 1. So now we cleared our terms of pi. It's just a fancy way of just saying, hey, terms of pi means you have pi left in your answer. That's it. Okay? So now we have 288 equals 4/3 r cubed. Okay? So now you have one best friend. Don't worry about this just yet. Don't stress on that. So send home your 4/3. You're gonna divide it by 4/3. Okay? Yes, I know when you divide fractions, you end up multiplying by its reciprocal, but since we're using calculators, it makes it easier. Okay? So 4/3 divided by 4/3 is 1. Now on your calculator, go 288 divided by 4 ABC 3. Okay? 288 divided by 4 ABC 3. And you get 216. Nice number. Okay? So now we're almost there. We have r. Okay? Now, this is saying r cubed. So some number being multiplied 3 times is going to get 216. So r times r times r equals 216. The way that you undo that, I wish I was there, it's called a cube root. So you undo a square, you take the square root. So here's what it looks like. It's going to look a little funky, okay? You're going to do the square root symbol. Okay? On both sides. But we're going to undo this cube. So we're going to take the cube root. So you're going to put a little 3 in this little, I don't know if you want to call it a space or a pocket or whatever. I don't know. But it's just right there. Okay? That undoes the cube. So what you end up having is you're going to cross off your 3's and you're going to cross off this guy. I'm going to make it bigger over here so you can actually see it. Okay? So you have r equals, now you have the cube root of 216. That's how you say that. You always read the power first. So to do that on the calculator, clear out your screen. Okay? You see above, gosh, I can't even see it on my glasses on. You see above the caret key, you have that itty bitty super fine blue writing. Oh boy. There it is. Okay? It has an X and then the square root. That undoes the caret. So it's the inverse of the key. Okay? So here's how you do this. You're taking the cube root of 216. Right there. Okay? So here we go. Clear your screen. 3 second caret key. Okay? So what I'm telling the calculator to do is I'm going to take the cube root. Okay? The cube root. Now put in 216 and hit enter. There you go. So r equals 6. So the radius is 6 inches. Let's do that again. Okay. So we're going to enter this in the calculator. So we want to find the cube root of 216. So go 3, just regular 3, second caret. The caret is that triangle with no bottom. It's right there. Okay. So that's what it looks like. And go 216. There you go. You just took the cube root. Okay. And your units are just in inches. Because remember, it's just the volume part that has cubic inches, not the dimensions. All right. Now let me show you what this looks like. So I'm just going to rewrite it. So I had r cubed equals 216. Okay. So I am just rewriting this part over here so you can see what I was doing. Make it a little bit bigger. Okay. So I'm going to undo this cube. So I'm going to write the square root symbol. Okay. And I'm going to put a 3 right here and a 3 right there. Okay. This is what I did over here. It's just, it's hard to see. Now, these guys undo each other. So you cross off the 3's and I cross off that square root symbol. So I just have r in here. Okay. It gets kind of messy. So you end up with r equals the cube root of 216. Okay. So there you go. You just found the volume of a sphere. I would normally do more examples, but I'm already at 25 minutes because I knew the discussion would take a while about spheres and how do you form a sphere and that kind of a thing. We could talk way more in class about this because I really want your opinions on why the sphere doesn't have a height. I imagine who would argue with me. Yeah, I'm not going to call any names out. But anyways, it's volume of a sphere. Have a good night.